Good morning, students. In the last class, I gave definition for network analysis and what is network analysis and what is network synthesis. Also, we understood. Now, to continue further with network analysis, next in network analysis throughout, we have to assume LLFPB network. LLFPB network. What do you mean by LLFPB network? So here there are five symbols. First L stands for lumped. Second L stands for linear. Third letter F stands for finite. P stands for passive and B stands for bilateral. LLFPB elements. All the elements are supposed to be LLFPB elements. Now we shall take up these elements, these definitions one by one. First, lumped. For example, if you take a wire, as we know that resistance is proportional to length. As length extends, resistance also going to increase. L is proportional, resistance is proportional to length. Therefore, if this is an element and if it is supposed to be wire and these two are terminals, then how do we represent resistance? So resistance is to be represented like this. But we are concerned with voltage and current measurement at the terminals. What is voltage between these two terminals? For example, V is voltage. And I is current. I stands for current. Entering one terminal, coming out at the other. As voltage and current measurements are made at terminals, we assume that the resistance is assumed to be concentrated at a single point. If you assume it is to be concentrated, it is at a fixed point, then it is represented like this. Then this resistance is what is called as lumped resistance. So if the parameter is assumed to be concentrated at a single point, then it is said to be lumped resistance. This is what is called as lumped resistance. Similarly, lumped inductance, lumped capacitance. And opposite to this word lumped is distributed. So distribution of parameters comes in the case of transmission lines, then antennas, etc. But for the time being, we are concerned only with lumped elements, and the parameters are supposed to be concentrated at a single point. They are called as lumped parameters. Lumped resistance, lumped inductance, lumped capacitance. Now, we shall go to next item, linear. What is linear? Linear element. When do you say an element is linear? V is voltage between the terminals. I is current through the terminals. What exactly is the relationship between V and I? If V and I relationship is a straight line, then it is said to be a linear element. So for a linear element, the relationship between V and I is proportional. So proportional current change, for a proportional current change, there is proportional voltage change. This is said to be a linear element. Sometimes the relationship takes the form of a parabola. Then it is said to be non-linear. So when there is no relationship like this, then it is said to be non-linear. We assume that elements are all supposed to be linear. Okay. Next, lumped linear. Finite. Finite means definite. So if the parameter value is finite, then it is said to be a finite element. Now the next definition is P. P stands for passive. Next definition is passive element. So when do we say the element is passive? Passive elements are always going to absorb power. They absorb power. For example, if this passive element is absorbing power, current enters at the positive terminal and current comes out at negative terminal. This is what is called as passive element. Passive resistor, inductor, capacitor. So all passive elements are going to absorb power. They are not in a position to supply power. They absorb power. So current enters at, always keep it in mind, when an element is absorbing power, current enters at positive terminal and current comes out at negative terminal. Opposite to passive element is what is known as active element. When do you say an element is active? An active element, this is an active element. An active element not only supplies power but also absorbs power. So they are energy elements. So for example, if this element is an active element, then it supplies power. When it is supplying power, it supplies power to the circuit, then current comes out at positive terminal. Opposite to passive element, current comes out at positive terminal and current enters at negative terminal. So this is what is called as active element. So active elements opposite to passive. And lastly, bilateral. Bilateral elements means conduction in both the directions. So from here to here, for example, a resistor. A resistor is a bilateral element. A resistor is a bilateral element. See, it conducts current in this direction when this is plus and this is minus. And it equally conducts in the other direction also. If it conducts equally well in the other direction, then it is said to be a what is known as bilateral element. For example, diode. Diode is not a bilateral element. Diode is a unilateral element. It conducts well only in one direction when anode is positive, is forward biased and cathode is reverse biased. So this is all about LLFPB definition. Thank you.